Let's talk about average velocity. When you find average velocity, you're just taking the distance traveled and dividing that by the amount of time taken. And the thing that makes it average is the fact that you're doing it over some length of time. So just a simple example is if you drive 150 miles in 2 hours, your average velocity is 75 miles per hour. You do that by doing 150 divided by 2. Now, in most of the problems that we look at, instead of just being given the distance and time, we're going to have to compute them from one point in time to another. So this example here, a rock is dropped off of a building 100 meters tall. The height of the rock after t seconds is given by this function. Find its average velocity. So the formula we're going to use for this is average velocity is equal to the position, in this case the position is h or height, position at time A minus the position at time B over A to B, or time A minus time B. In this case, our times are 3 and 3.2. Now, it doesn't matter which one we call A and which one we call B, but I think it makes a little more sense to start with the bigger number. But it really makes no difference. So let's see, the average velocity from 3 to 3.2, that's going to be h of 3.2 minus h of 3 over 3.2 minus 3. All right, I'm going to use my calculator here. 100 minus 4.9 times 3.2 squared. That is exactly 49.824. And h of 3 is 100 minus 4.9 times 3 squared. That's 55.9. And then 3.2 minus 3, I can do that without my calculator, is 0.2. And if we do this, let's see, 49.824 minus 55.9 equals that, divided by 0.2, gives me negative 30.38. And let's see, my units here are meters per second. So that's the average velocity of this rock during that time. Now it's negative because it's going down. If we were to graph this, we'd see that starting off, the rock would go, or no, the rock's dropped off of the building. So it starts up here at a height of 100, and as t goes on, it's going to go down. So it makes good sense that the velocity is negative because the height is changing in a negative fashion because it's falling. All right. Let's look at another example of this. A bicyclist starts at mile marker 0 and rides along a road. And this table tells his location at various times in minutes. So in this case, it's not written out as a function, but we could think of the minutes here as being our t, and this down here, the distance, as being our f of t. So what we need to do for finding his average velocity over some interval of time is to do f of a minus f of b over a minus b. In this case, our a and b are here. So his average velocity from t equals 0 to t equals 70, we just need to pull those numbers off of the table. We've got f of 70 minus f of 0 over 70 minus 0. So f of 70 is 26. F of 0. 0 is not on the table, but they told us up here that the mile marker 0, at mile marker 0 is where he starts. So even though they didn't tell us to us, we know that 0, 0 is one of the points up here. And let's see, 70 minutes minus 0. So this is just 26 over 70. 26 over 70 is 13 over 35. Let's see, this is in miles per minute. And we could convert that to a fraction, to a decimal if we wanted, but fractions are fine. All right, now to determine its velocity from t equals 20 to t equals 40, that's supposed to be an equal there. We just do f of 40 minus f of 20 over 40 minus 20. And let's see, 40 minus 20 is on the bottom. F of 40 minus f of 20, we just have to come up here to the table and find it. Let's see, f of 20 is 7. F of 40 is 16. So 16 minus 7 is 9 over 20. So 9 over 20 miles per minute. All right. And that's it, I believe, for examples of average velocity.